The temperature in Anchorage, Alaska has ranged anywhere from 60 below zero to 85 above zero. Was it 65 degrees? Yes. Was it 85 or 60 degrees? 85? Yes. A lot of people are having a hard time figuring out when to put that or equal to. It was as low as 60. You're filling this out with me. It was as high as 85. That was the temperature. Now I have to figure out. Here's a hint if you haven't figured it out by now. As long as your numbers are in order in terms of how they are on a number line, your symbols will always point to the left, right? That's not the only correct answer. If somebody said, well, I just have it as 85 and negative 60, that's okay. You just have to make sure that the temperature compared to 60 was greater than or equal, and compared to 85 was less than or equal. So they're either both going to go left or right when it's an in-between. If you have it where the number goes on the number line, they're going to go this way. You're going to have to translate. Actually, there's no translating here. All numbers greater than 5 and less than 12. So if I were you, I might take a highlighter out for your test and just kind of highlight whether it's an and or an or. Okay? So I'm thinking of all numbers that are greater than 5 but less than 12. That's one way to write it. If you wanted to say all numbers with the 5 here and a 12 there, it's greater than 5 but less than 12, whichever way. Okay, the graph is going to be the most important part of this. Your graph is going to tell you everything you need to know. And if you look at the practice test, which by the way looks exactly like the real test, what do you see for every problem? A graph. Because it's the graph that you're going to interpret to find your answer. So what does a graph like this work out to look like? It looks like 5 here, 12 there, can't be 12, can't be 5, but it can be anything less than 12, but greater than 5. And you know what? If I were you, I've been using a red marker and kind of using this, because in and, what are we looking for? Overlap. Okay? And that is the easiest thing that's going to help you figure out if you graphed it correctly, your answer is where the overlap is. Okay? Now let's take a look at the or. Or I don't need an overlap. Or I just need where there to be any line. So all numbers that are less than 5 or greater than 12. Okay? Oops, sorry. Don't do that. I was looking at the and. Because guess what? You cannot write your ors as a combined. So you know what we have to do? We have to say all numbers that are less than 5 or all numbers that are greater than 12. Okay, so it's got to stay separate like that. Now let's take a look at this graph. If 5 is here and 12 is there, here's greater than 12, here's less than 5. Okay, so this is kind of unique because, actually it's not unique, this is like pretty standard. This is what your typical and looks like. They cross over. This is what your typical or looks like. Meaning, what is your answer? It's the inequalities. That's your answer. So your graph is telling you this. Your inequality is telling you that. Now, we know that something weird happens with the special cases, right? Let's write this one. The sum of negative 2x and 3, take it one step at a time, is less than 18. And because it's an and, I can write it combined and it's greater than 20. So this one's a little step above these two because I didn't come right out and give it to you. I have you having to solve it now. So you're going to subtract 3 from all 3 sides. You're going to get 17 is less than negative 2x, which is less than 15. Okay? And now I'm going to divide by, so Chris, I really need you to put the book away and pay attention, okay? So I'm going to divide all 3 sides by negative 2. And because I just divided by a negative, what do? So this is going to give me negative 6, 7.5. Where are we at? Wait, what are we doing? Oh, this is 8.5. Sorry, I can't even do this today. I'm thinking of the other example. Flip it. This divides and leaves me with x. And this is going to give me what? Oops. That's the 7.5. There. Greater than negative 7.5. Okay, graph it. Here's 0. Here's negative 8.5. Here's negative 7.5. The spacing is not exact, obviously. Now, if I say x is greater than negative 7.5, x is less than negative 8.5, okay? This is not your typical and, is it? This is what your graph usually looks like when it's an or, because it's this or that. So what would your solution be if this was an and? We talked about this. It was in our special cases, Connor. Empty set. Do you see overlap anywhere? No. So if I'm looking for overlap, there isn't any, which means when your graph looks like that and that happens, your answer is empty set. It means that your set of numbers that fits this solution that's greater than this and less than this is empty. There are no numbers that exist, okay? All right, so this backside is actually going to be the best, all right? It's going to give you a visual of a quick study guide. So if your graph looks like, I'm going to use 5 and 10 for all of them. 5 and 10. If your graph looks like this, that's the first way. Versus if your graph looks like this. What's the other type of graph that we haven't talked about yet? Here they both cross each other. Here they go the opposite directions. What are the other two? When they both go the same direction. So this would be same direction to the right. This one we'll just keep it consistent, do them all. This would be same direction to the left. And then I left one more space because you're going to see it today. And we're going to talk about that. I know, it looks weird, doesn't it? Okay. So, do you agree this is really kind of all the possibilities, at least right now, what we're talking about? They're going to go the same opposite directions and cross. They're going to go opposite directions and not cross. Same direction to the right, same direction to the left, same exact number, opposite directions. All right, you ready? What's that? Yes, we're going to talk about that. All right, so let's just say this is 5. This is kind of cool because if you solve it all out and your graph looks like that, if the problem were an and, you would have one answer. If the problem given were an or, your answer would be a different answer. So can we fill these out together? So if this was an and, what would your answer be? Basically a compound inequality. Okay, what would it look like, Evan?
It would be 6, 7, 8, 9, and 10.
Good. He said it would be 6, 7, 8, 9, and 10. So you could say, yeah, x could be 6, 7, 8, 9, and 10. I'll accept that. In addition to your actual inequality, the best way to write that would be all numbers that can't be 5 in between 10 and 5, including 10. Agreed? This is one way, this is another. This is you have to write this way. You can write that way if you want, in addition to it. If this was an or, I don't need overlap for ors. Anybody have any idea how that would look if your answer was if your graph looked like this and it was an or? Hey, let's just use common sense for a minute. Hey, give me a number that's greater than 5. 6, 7, 8, and every number in that direction. You don't want to use that one? So give me a number less than or equal to 10. 9, 8, 7, or every number in this direction. Isn't every single number a choice? Every single number you say will fit one or the other. So how do we say every single number? All real numbers, okay? So when your graph looks like that and it's an or, because you don't need overlap, it's everything, okay? If this were my graph and it was an and problem, really quickly, we talked about this on the back page, it would be what? Empty set. If this were your graph and your question was an or, it's pretty simple. It's just the two inequalities that you're looking at. Meaning, any number less than 5 or any number greater than or equal to 10. Your graph is your answer. You just have to write it in inequality form. Now, I feel like this is what we had the least amount of practice on. If they're both going the same way, and in an and I look for overlap, where does the overlap begin? Does it begin at 6? No. It doesn't begin until what? Until that inequality. Agreed? So for ors, if I don't need overlap, you know what I do? I back up. And so where will a number be at least greater than 5? Starting at x is greater than 5. So for when they both point the same direction, this is really important. One of the inequalities is for the and the other one, back it up, is for the or. Does that make sense? So how about that one? Where does the overlap start here? Not until a number less than 5. Back it up for the or, and where does it one or the other? Less than or equal to 10. You have to write the full inequality. All right, this one's unique. Last one, and then you guys are going to be practicing these. So what if you get something that says, because by the way, this is x is greater than 5, x is less than 5, right? So normally we have like two different numbers, but what happens if you solve an equation and they're both 5? And one says less than and one says greater than. I want you to think about what that would be if your solution was an and. Or if your problem was an and. Is there any overlap anywhere? No. What if your solution, what if it's asking you for an or problem? Think about this one. It's kind of like this one. Almost every number would work because every number this way would work.
All numbers except.
Yes. So all numbers except 5. Another way to write that is x could not equal 5, and then every other number is fair game, okay? This is a very awesome visual to help you. This is every single type of problem you're going to see when we take that assessment, okay? Big study guide. You are not going to get to use it on the test.